Hello students, myself Dr. Divya, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will discuss the problems on higher calorific value and lower calorific value of a fuel. So before that, we should understand what is the calorific value of any of the fuels, which gives its capability of burning and giving the energy. So the calorific value or the heating value of a solid or liquid fuel may be defined as the amount of heat given out by complete combustion of 1 kg of fuel. So the amount of heat produced upon with combustion of 1 kg of fuel. So that gives the understanding of calorific value. So this is very important parameter for any fuel to understand, so that only then we will be able to give it in any of the applications like machineries or automobiles. So it is expressed in the form of kilocalories per kg whenever we are giving out for the kg at normal temperature and pressure conditions. So in the SI systems, if you see joules per kg or kilojoules per kg or megajoules per kg. So these are the units for the calorific value. So the calorific value has a very high importance and significance for any of the fuel like solid and liquid fuels. So for example, coal, or in the solid fuels, coal, and liquid fuels like petroleum or any of the products like diesel. So these will give an idea of how we can use it for any of the automobiles or machineries. So if you see, there are two types of calorific value. Higher calorific value and lower calorific value. There are two types of calorific values. So let us see what are these higher and lower calorific values. So higher calorific value of any fuel is also called as gross, which indicates the complete calorific value of any of the defined fuel. So it is the total heat that is liberated by complete combustion or burning of 1 kg or 1 cubic meter of fuel. So this is nothing but the total heat that is liberated. Total heat that is liberated is nothing but the higher calorific value. When it is totally combustion takes place, it is more in nature. So therefore we are calling as higher calorific value, or also called as gross calorific value. So that also includes the total whenever we have moisture in the fuel. That also includes moisture in fuel also is considered in this. So that will give rise to steam on combustion. So steam is also produced on combustion. So this is also calculated or taken into consideration for the higher calorific value. So the heat of steam formed by combustion of hydrogen is also considered in the higher calorific value or gross calorific value. So a scientist called Dulong's had proposed a formula, that is HCV, or the higher calorific value, is equal to 33,800 carbon into carbon plus, this is carbon plus 1,44,000 taken in the brackets hydrogen minus oxygen by 8. 8 is nothing but for the oxygen, atomic weight, and plus 9270 sulfur, oxygen, hydrogen. So these are the main constituents that contribute to the heat. So therefore these are considered in the higher calorific value, and the units are given in the form of kg, kilojoules per kg. So this is a standard formula that we will be using for the higher calorific value. The next is the lower calorific value or the net calorific value. What is this lower or the net? It is the total heat liberated by complete burning of 1 kg or 1 cubic meter of fuel, deducting heat of steam. Heat of steam is not useful for the any running automobiles or machinery. Therefore, we are not considering this heat of steam in the net calorific value. Net is nothing but the calorific value that is considered while we are using or utilizing for any of the machineries or automobiles. So the heat of steam to be removed or detected so that we get the net calorific value or the calorific value actual calorific value of a fuel. So this is nothing but the lower calorific value or net calorific value. So if we want to remove that heat of steam, we have to obviously remove it from the higher calorific value that includes this heat of steam. Therefore, lower calorific value is equal to higher calorific value minus 9 into hydrogen. So why are we doing this? Because hydrogen is contributing in producing the steam. Therefore, we are subtracting that into 2466 kilojoules per kg. So this is a constant after experimentation. Dulong's has proposed this formula wherein we get HCV minus 9H2 into 2466. That is the formula for the lower calorific value. So this is also given in the form of kilojoules per kg. So these are the units that we will be using for the expression of higher and lower calorific values. Okay, so these two are very important to consider before we utilize the fuel for any of the machineries or automobiles. Next, so these are the important formulae that we have, like theoretical calorific value of fuel, that is nothing but the 33,800 carbon plus 1,44,000 taken into multiplied by hydrogen minus oxygen divided by 8 plus 9270 sulfur. So this we have to consider for the HCV. So this is nothing but HCV or the higher calorific value, and the lower calorific value as we discussed in the previous slide, HCV minus 9H2 into 2466 and given in the form of kilojoules per kg. This is also kilojoules per kg, this is also kilojoules per kg. Okay, then we have one more formula like mass of air required for complete combustion. So combustion doesn't take place just like that. So it requires some air for its combustion. So that is nothing but we should be able to also calculate this mass of air required for complete combustion of this kg fuel. So that is given by 100 by 23 into 26.7 carbon plus 8H2 plus sulfur minus oxygen. So that gives the amount of, it is only the mass, therefore it is only given in the form of kg. So the mass of excess air that is supplied. So we have also been seen the cases wherein excess of air is supplied. So in that case, 100 by 23 into mass of excess oxygen is given. So this is how we will calculate the mass of air required and the mass of excess air supplied. So now in this session we will discuss only HCV and LCV for the calculation of for any of the fuel. So if you see this problem, a sample of coal has the following composition on mass basis. So that is, they are given in the form of percentages. So carbon is 82%, hydrogen is 8%, carbon 82%, hydrogen is 8%, okay, oxygen is 4% and ash is 4%. Okay, now calculate using Dulong's formula higher and lower calorific value of a fuel. So the given is now converted into mass. So that is given in the form of 0.82 and hydrogen, if it is 0.8%, it is 0.08 and sulfur 0.02 and oxygen 0.04 and ash is also 0.04. So Dulong's formula, we know that HCV is equal to 33,800 carbon plus 1,44,000 multiplied by hydrogen minus oxygen by 8 plus 9270 sulfur. So these are the units. These are the units, kilojoule per kg. So whenever they are given in the form of like percentages, it is obviously like given in the form of kg. Now substitute the values in this formula. 33,800 into what is the for the carbon, how much is it? 0.82. So 0.82 is multiplied here, substituting the value, then 1,44,000 taken in brackets, 0.08 for the hydrogen. How much is the hydrogen? 0.08 minus 0.04 is for the oxygen, divided by 8. So plus 9270 into 0.02, that is for the sulfur. So upon simplification and calculation, we get 27716 plus 10800 plus 185.4. So upon addition, we get 38,701.4 kilojoules per kg. So if you see, always the HCV will be higher. HCV will be higher. Why? Because it is containing even the moisture, that is like heat of steam. Okay, so now we calculate the LCV or lower calorific value, that is given with the formula HCV minus 9H2 into 2466. So now substitute that HCV value that we got, 38701.4 minus 9 into 0.08. What is the 0.08 for the hydrogen that we are considering? So 0.08 into 2466 is equal to, upon simplification and calculation, we get this value 38701.4, and this n, if you see, always keep it constant, this one, and do the calculation for this n, and next subtract. So we get a value of 36,925.88 kilojoules per kg. So this is the higher and lower calorific value for that coal sample. So considering this, we will be applying for any of the practical applications. Next, we again have a coal sample having the composition on mass basis. So carbon is 76%, hydrogen is 5%, sulfur is 1.5%, oxygen is 8.5%, ash is 7%. Now we convert into normal values, and now calculate the higher and lower calorific value of a fuel per kg. So given the composition on the coal on mass basis, so carbon will be 0.76 and hydrogen is 0.05, sulfur is 0.015, oxygen is 0.085 and ash is 0.07. And we know the Dulong's formula, HCV is equal to 33,800 carbon plus 1,44,000 taken hydrogen minus oxygen by 8 plus 9270 sulfur. So this is the units. This is the units. Okay. Now substitute the values in the formula, 33,800 into 0.76. So for carbon it is 0.76 and substitute here. Then 1,44,000 and how what is the hydrogen value? 0.05 minus oxygen, how much is it? 0.085 divided by 8. Okay, next plus 9270 into how much is the sulfur? 0.015. So this is how we will be substituting the values. Okay, 33,800 into 0.76. So upon calculation, we get the value of 31497.05 kilojoules per kg. Always remember the units. Units have very importance and significance. Without units, the value is of no value. So whenever we report, we have to also write the units. Okay. So this is how, this is the HCV value, HCV or the higher calorific value. So this is high and lower calorific value. Now substitute higher calorific value 31497.05 minus 9 into how much is the hydrogen? 0.05. Okay, into 2466, and we get, after substitution and simplification, we get it is 30,387.35 kilojoules per kg. So if you see, always lower calorific value is less compared to higher calorific value. Next, a sample of coal has the following composition on mass basis. So the carbon is 75%, hydrogen is 6%, then sulfur is 1.5%, oxygen is 8%, and ash is 7%. Calculate the HCV and LCV values of the fuel per kg, kilojoule per kg. Okay, so the given composition, carbon is now converted into values like 0.75, hydrogen 0.06, and sulfur is 0.015, oxygen is 0.08, and ash is 0.07. Now substitute in the Dulong's formula, 33,800 into carbon. How much is the carbon? 0.75 plus 1,44,000, and taken in the bracket hydrogen 0.06 minus oxygen. How much is the oxygen? 0.08 by 8. Okay, plus 9270 into how much is the sulfur? Sulfur is 0.015. So upon simplification and calculation, we get 32,689.05 kilojoules per kg. So this is the HCV value of this coal sample. Next, LCV. Now substitute this 32,689.05 kilojoules minus 9 into hydrogen. How much is the hydrogen? 0.06 into 2466. So this is the formula, and we are substituting, and upon calculation we get 31,357.41 kilojoules per kg. So K is also capital because kilojoules per kg. Okay, so this is the LCV value, HCV and LCV values. So whenever there is some confusion, you have to take care of the values, because HCV is always higher, so it will have the high value, and LCV is lower and it will have lower values. Okay, so next, a coal sample has the following composition. So carbon is 60%, hydrogen is 10%, sulfur is 3.5%, oxygen is 15%. If you see, oxygen content is very high here. So calculate the higher and lower calorific values of fuel per kg. So now convert into values like carbon 0.6, hydrogen is 0.1, sulfur is 0.035, oxygen is 0.15. So if there is an oxygen, it means that it has moisture content also, so we get higher. It could be because of moisture also. So the steam, it also produces steam, heat of steam. Okay, so this is the Dulong's formula that we have. So 33, how much is this? 33,800 into how much is the carbon? 0.6 plus 144,000. Hydrogen, how much is the hydrogen? 0.10 minus oxygen 0.15 by 8. So close the brackets properly. Then plus 9270 into sulfur. How much is the sulfur? 0.035. So upon simplification and calculation, we get 32,304.45 kilojoules per kg. So this is the HCV value. And LCV value, substitute this HCV value here, minus 9 into hydrogen 0.1 into 2466, that is equal to, like upon calculation and subtraction, we get 30,085.05 kilojoules per kg. So this is the LCV value. So this is the HCV and LCV value for that coal sample. So if you see, this is 30 and this is 32. So 2000 kilojoules per kg is just because of heat of steam. So that is how whenever there is oxygen content, the HCV value will be higher because of that heat of steam, because that is present due to moisture in that coal sample. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.